In the high-stakes theater of modern technology statecraft, we have been told a massive lie. We've been led to believe that the future of artificial intelligence, automated transportation, and municipal scale lies in the cloud. It doesn't. The centralized cloud, as we currently know it, is fundamentally dying. It is pacing toward an absolute, unyielding physical barrier, the latency wall. Consider this immediate reality. A single autonomous vehicle operating inside a next-generation cognitive city generates up to 4 terabytes of raw sensor data every single day. If that vehicle encounters a sudden obstacle, a pedestrian, or a collapsing transit loop, the decision to apply the brakes must happen in less than 10 milliseconds. If that sensor data has to travel 500 miles to a centralized cloud data center and travel back, you incur a delay of 50 to 200 milliseconds. That lag isn't just an inefficiency, it is a physical disaster. Welcome back to the channel. I am Dr. Usman Zafar. Over the past month, we have broken down how automated governance is rewriting our foundational networks. Today, we are analyzing the next multi-billion-dollar infrastructure shift. The world's most advanced smart city frameworks are aggressively decoupling from remote cloud monopolies. They are relocating their entire computing brains directly onto the street. This is the rise of sovereign edge infrastructure, and today we expose the exact architectural mechanics. To understand the structural collapse of centralized cloud frameworks, we have to look at the sheer volume of data being pushed through our networks. The International Data Corporation estimates that globally, the volume of newly generated data will hit approximately 180 zettabytes. Think about that scale. If we try to push 180 zettabytes of raw data back to centralized servers, our international fiber optic backhauls will completely buckle under the bandwidth weight. This is the structural breakdown that legacy providers don't want to confront. Centralized computing was perfectly optimized for the mobile web era. But cognitive urban designs require real-time execution. Processing data locally at the network edge cuts that latency down to a staggering 1 to 10 milliseconds. By processing information directly at the device level, we eliminate the physical distance data has to travel. We are entering the era of physical proximity. The transition to localized urban computation is built upon a highly definitive 3-pillar architectural framework. Pillar 1 is the deployment of multi-access edge compute, or MEC infrastructure. Smart city planners are no longer leaving processing power inside distant server farms. They are mounting micro-supercomputers directly to physical urban assets, installing localized processing units inside traffic lights and roadside cabinets. Instead of streaming gigabytes of raw video to the cloud, the edge node runs computer vision models locally and flushes out the useless raw data instantly. Pillar 2 is intellectual composable hardware. Edge nodes must execute complex neural networks under diverse, harsh physical conditions, operating with zero direct support. This has caused a massive industrial spending race. The hardware sector has scaled intensely, now commanding a dominant share of edge infrastructure budgets. Global tech enterprises are pouring billions into ruggedized converged systems, deploying high-performing on-premise components that process advanced machine learning logic entirely at the hardware device layer. Pillar 3 is the hybrid hyper-orchestration layer. Moving to the edge does not mean completely erasing the cloud, it means redefining its purpose. The edge handles split-second life-critical actions, adaptive braking, instant accident detection, and localized power grid balancing. The remote cloud is pushed back into a secondary role, serving as a long-term storage vault for deep historical analysis and system-wide software updates. This isn't an architectural theory. The transition is happening rapidly on a global scale. Nearly 60% of all global network traffic will be processed at the edge. By next year, approximately 26% of all global network edge sites will be concentrated inside China alone, driven by massive state deployments aimed at reducing systemic backhaul network costs. On the commercial front, the industrial Internet of Things and smart city logistics make up the absolute largest market segment. Automated robots require 20 milliseconds response times. A simple 1-second cloud latency lag on an automated line running 60 parts per second results in immediate asset destruction and catastrophic equipment failure. This operational reality is exactly why 97% of enterprise CIOs have now placed Edge AI directly onto their near-term technology deployment roadmaps. And here is the critical leverage point for small and medium enterprises. Historically, building a global technology footprint required massive capital deployment. But with localized edge processing, an agile SME can deploy an independent on-premise hardware node right inside their facility without paying continuous cloud premiums. The shift toward edge computing is ultimately a battle for structural sovereignty. When a nation or an enterprise processes all of its critical operational data inside a remote, centralized cloud owned by a foreign conglomerate, they have effectively signed away their infrastructure autonomy. Edge architecture redraws the digital balance of power, keeping data localized, private, and hypersecure. The computing brain is returning to the physical street. Is your organization building on localized infrastructure, or are you still vulnerable to the latency wall? Let me know your thoughts in the comments below. Make sure to hit that subscribe button. For a deep dive operational guide, secure your copy of my book, SME Leaders and Artificial Intelligence. Visit usmanzafar.com today. Stay sharp, stay analytical, and I will see you in the next masterclass.